Hello to everybody, I'm Marco Beato, Associate Professor in Sports Science. Today I want to make a tutorial for you about one-way repetitive measure ANOVA. So, as you can see here, we have our data. We have a single group, in this specific case, with this subject indicated with the letter A from the column 1 to 15. And after you have three variable. You can see that you have the continuous jump base, so continuous jump baseline, continuous jump mid, so a test performed, for example, after some weeks of training, let's say 4 weeks, and the continuous jump post, that is our final test after, for example, 8 weeks of training. So we need to check in this case if there is a variation from our continuous jump baseline to mid and post, so during the training period. So if we want to do an analysis here, we need to do a ANOVA, but specifically a repetitive measure ANOVA. In this case, a normal ANOVA is not correct because ANOVA analyzes, for example, difference between groups. In this case, we have the same group that repeat the test in different occasions. So you can have like 3 measures, you can have 4 time points, 10 time points. In this case, we have only 3, base, mid, and post. So when we open our repetitive measure ANOVA page, you can see that we have our variables here, and we have some cells here. So the first point is to understand what type of variables need to move in these cells. So I need to go here, click, for example, continuous jump, because it's what we wanted to assess in our specific analysis. So continuous jump, how this variable change during time. We have continuous jump base, that is our baseline as level 1, continuous jump mid as midpoint, and after we need to add the third level, that is continuous jump post. At this point, we can start to move our variables in our cells. So that are the repetitive measure cells. We move our 3 continuous jump variables here, and we don't move the group variable here in between subject factors, because we don't have any between subject factor analysis, because we have a single group. In this case, if you had, for example, 2 groups or 3 groups like A, B, and C, you could move the group variable here. So this one, the repetitive measure analysis, is a within analysis or a time analysis. This one is a between group analysis. And if you have any covariate, you can move the covariate here. We don't have this covariate in this moment, so we don't need to do anything. So now I open a bit the page, so probably you can see a bit better, because we don't need to see the original data set anymore. So here, after that we're done, we have moved the repetitive measure cells here, we can see that we have already our within subject analysis and effect. Here you have your F value, and here you have your P value. So we know already that there is a significant difference between these repetitive measures in our analysis, and this is reported by the P value that is minor 0.01. So here we have quite a large significant effect. However, our analysis is not finished, as you can understand. So my suggestion is to start always with the descriptive statistics. So probably is also something that you can do before. I recorded a video about the descriptive analysis, so you can check also that video. But if you jump directly on this analysis, like sometimes students, researchers, practitioners do, remember to add the descriptive analysis here. And if you watch the mean, you see immediately that there is quite a big difference in the post, but there is not much difference between the base and mid. Actually, the mean is lower in the mid, so we don't expect a difference that is significant between the two, but we will see very likely a difference between first and third, second and third data point. And on the right here, you have the standard deviation. So remember that generally we report always mean and standard deviation. So to improve our analysis, we can add an effect size. If I click here, you see that you have your eta square here nearby the p-value. So when you report the data, usually you report the f-value, the p-value, but also the eta square. Here you can see that you have also a partial eta square, you have a general eta square, and a omega square. In this case, for this analysis, this effect size is correct. So after a suggestion that I do always is to add the assumption check. So this is something that we should do every time that we run this analysis, because this one is a parametric analysis. So in some cases, some assumptions are not reached. So you need to take some action to correct the data. So let's click here on sphericity. This one is our assumption, and you can see that the p-value is greater than 0.05. So it's mean that the data are respect this assumption of sphericity. If the value was minor 0.05, it means that this assumption is rejected. So technically, you need to take some action, some additional action to correct your analysis. So in the case that that happens, you can click here on sphericity correction. So your model still correct. You can progress with your analysis, but probably you have an adjustment on the p-value. But in our case, this assumption is correct, is not rejected, so we can progress. After that we've done this is the first analysis, my suggestion is to add a post-hoc analysis, because we want to see the difference between each of these data points. So the post-hoc analysis in this case show us the difference between control jump base and mid, control jump base and post, and after mid and post. And how we said before, we find the difference that is significant between base and post, and mid and post. So we don't have a difference between the based control jump and the control jump mid. And this is something that we could see directly from the descriptive analysis, but here we have statistical confirmation of this difference. So the next step is to add the effect size of the post-hoc, because the first effect size, the eta square, is the effect size of the whole ANOVA. Doesn't tell you the difference, the standardized difference between each comparison. If you want to have that, you need to do that in the post-hoc analysis. And in this case, as you can see, we have a QND. The QND is the standard effect size for this type of analysis. Coming back on the post-hoc, you can see that you have different correction. In this case, you can change on Bonferroni, Tukey, and Sheffield. But for this analysis, the post-hoc with the Olm correction is correct. So you don't need to have Bonferroni, although you can have also a Bonferroni. The next step is to draft a plot. So if you go here on descriptive plot, you have your factors, control jump. In this case, we move this variable here on horizontal axis, and you will see that the software calculates for us the plot. My suggestion is to add the confidence interval on the picture, and here you have a better indication about the mean, and also the dispersion of the data around the mean with a 95% confidence interval. Also, you can increase the size of this graph, and you can also export that. So at this point, we can say that our analysis is complete. There is the chance to do some additional analysis or to have different plots, but for our analysis, we can say that we could be happy also with this level of detail. So coming back, we have the within subject effect with f-value, p-value, and effect size. Here you have your descriptive analysis. Here you have your plot with a confidence interval, 95%. Here you have also your assumption check that you need to do before to run all this type of analysis, but here is reporting in this position. And finally, you have the post-hoc with the t-value, QND, and p-value corrected with the Olm correction. And clearly, as you can see, control jump base is different compared to control jump post, and control jump mid is different compared to post. So clearly the effect of this training, if we suppose that there's been a training, has been successful after the mid time point. Probably something was changed after this specific data point, and the athletes in this case improved their control jump performance from this average that is 28.4, 28.2 until 32.06. Can we say that that is significant? Yes, because as we said, our post-hoc show a p-value that is minus 0.05, and was this difference say meaningful? So the effect size was quite large or not? Here you have your effect size, and you see that you have a difference of 1.2 or 1.3 that we know is quite large. Thank you very much. I hope you have enjoyed this video. If you like this type of videos, please subscribe to this channel. Thank you very much.